All right, let's continue and finish up question 3. Calculate the length of time in seconds required to plate 2.8 grams of RH onto a piece of sterling silver if 2.0 coulombs per second of current is applied. So this is a Faraday's law problem where there is an equation I'm going to use which looks like this. Ne equals I times T over F. What I'm being asked to solve for is T, or time. And what I'm going to need to solve this is Faraday's constant, which I actually wrote down here, which is off of the AP data table. I stands for current, and that's also given to me in this question. What I don't know, though, is the moles of electrons, or this Ne. So I need to know how many moles of electrons I have. But because I'm given a mass value of the RH metal, I can convert this into mole and do a mole ratio to figure out how many moles of electrons I have. So for example, I know the mass of this is 2.8 grams. The molar mass of this is 102.91 grams per mole. So the moles of this is 2.8 divided by 102.91 grams per mole. Okay, maybe I should write that down to show what I'm doing. So the moles of the RH solid is 0.0272 mole. So again, I'm going to do a mole ratio to figure out how many I need, not the moles of the element, but the moles of the electrons in this redox process. So if I bring this value over here, I'll write it down underneath. I'm going to say that the moles of electrons equals the moles of RH. Set up a ratio. Put the units you don't want on the denominator of your ratio. That's going to cancel out. So I don't want moles of RH. I do want moles of electrons. So that goes on the numerator. So if you look at your balance equation, what I can see is that for every 3 moles of electrons that are used, 1 mole of RH is produced. That will cancel this out and give me my moles of electrons, which is 0.0816 moles of electrons. So now I can plug these values into my Faraday's law formula and then isolate for time. Okay, so maybe we should rearrange the equation. Time equals Ne times F over current. Time equals moles of electrons, 0.0816 moles. Faraday's constant, 96,485 coulombs per mole. And again, be mindful of your units. Look at how they cancel out. Divided by current, 2.0 coulombs per second. So mole will cancel out with mole, coulombs will cancel out with coulombs, and then the seconds will reciprocal to the top. And that should give me a final answer of 3,900 seconds. Okay, and that's how we solve this Faraday's law problem.